Welcome to yet another lecture on energy management and energy conservation in thermal systems. Today we are going to discuss about very important utility in thermal systems, which is boilers. So our lecture will be divided into four parts, in which we will discuss about the boiler, furnaces, waste heat recovery, and use of insulation, types and application. So today we will discuss with boilers, then the next lecture will be on furnaces, then we will start with waste heat recovery, and then the use of insulation, its type and application. Then we will discuss about HVAC system, which is heating, ventilation and air conditioning, in which we will spend more time on understanding what is the meaning of coefficient of performance, that is COP, then capacity factors affecting refrigeration and air conditioning system performance, and savings opportunities. So in your previous semesters, you must have discussed about, or you must have come across the term called as boilers. So boiler is an enclosed vessel that provides a means for combustion heat to be transferred into water to become steam. So it is a device which converts water into steam, but then all equipment which converts water to steam cannot be considered as boiler, because there is a specifications required. So a steam generation unit will be called as boiler if it is certified by Indian Boiler Regulations. If it comes under the definition of Indian Boiler Regulations Act, that means it should have some the boiler attachments, or we can say the performance parameters which affects the boiler efficiency, then parameters. Okay, so you have the boiler mountings and also boiler accessories. So you have come across this term in your previous semesters. We will discuss more about the energy conservation point of view of boiler. So here is the introduction about boiler. A boiler is an enclosed vessel that provides a means for combustion heat to be transferred into water until it becomes heated water or steam. So your pressure cooker cannot be considered as boiler, even though it converts water into steam. The sole purpose of a pressure cooker is to cook food and not to provide steam. Okay. Then you will say, then what is the purpose of steamer? Whether it can be called as boiler. So in our further lecture, we will also discuss about what are the parameters that define a pressure vessel into a boiler. So the hot water or steam under pressure is then usable for transferring the heat to a process. So in general, it can also be called as a process steam. Okay. So water is a useful and cheap medium for transferring heat to a process. When water is boiled into steam, its volume increases up to 1600 times, producing a force that is almost an explosive or as gunpowder. That is why we say that the previous old age locomotives were used to run on steam. So steam has a great power, almost as an explosive. So the piston and cylinder arrangements in which the steam was passed converted the reciprocating motion into a rotary motion, which the steam engine used to run on, and it was a coal fired. So can anybody tell me that this locomotive is a vertical boiler or horizontal boiler? The steam locomotive that used to run by Indian Railways was a vertical boiler or horizontal boiler? In the chat section, you can comment on whether it is a horizontal boiler or vertical boiler. So locomotive is a horizontal boiler, which is yes, which it is a horizontal boiler. And can you tell me whether it is fire tube boiler or water tube boiler? Fire tube boiler or water tube boiler? Fire tube, that is correct. So in general, we see that the fire tube boilers fire tube boilers are low capacity or low heat boilers, in which the pressure of the steam is not to higher extent. So that is a yes, that you are correct. It is a fire tube boiler. So this causes the boiler to be extremely dangerous equipment that must be treated with utmost care, and that is why you see that it comes under the Indian boiler regulation. So Varun is asking what is difference between horizontal and vertical boilers. So it's just an arrangement of the fired, how it is fired. So you see if the tubes are arranged in a vertical manner with the flue gas going from the top, and the combustion is taking place from the bottom. Ash pit is there at the bottom. This is called as a vertical boiler. So normally our household boilers household boilers are vertical boilers. Okay, household boilers are there for heating water. These are vertical boilers, whereas the locomotive is a good example of horizontal boiler. Okay, then there are packaged boilers in which both the things are combined. Okay, that I will show you in the coming slides. So the process of heating a liquid until it reaches its gaseous state is called as evaporation. Okay, so heat is transferred from one body to another by means of radiation, which is the transfer of heat from hot body to a cold body without a conveying medium. This you have come across in fifth semester in heat and mass transfer. Then second is by convection, the transfer of heat by a conveying medium. So there is a medium through which the convection takes place, or in general, the movement of molecules from one portion to another is called as convection, such as air or water. And conduction is a transfer of heat by actual physical contact, molecule to molecule. So conduction is also having two parts, which is by means of lattice vibration and by means of transfer of molecules. So transfer of energy by molecules. So you see that conduction, convection, radiation, all these three means of heat transfer is observed in boiler. And if we recall the steam, if we recall the steam generation system, this one. So you see boiler has all these three phases to convert into steam. So you see A to B is sensible heating which occurs in boiler. B to C also occurs in boiler, which is the transfer of heat in a latent mode. That means conversion of water to steam. Then this part at C is called as saturated steam, and the boilers which operate at this below C is called as a uh, low capacity boilers. Okay, which operates at this point, which is 221.2 bar pressure and 374 degrees Celsius, are called as critical boilers. So critical boilers are those boilers in which the sensible part is removed, only conversion from water to steam takes place. These are called as critical boilers. Whereas the boilers which operates in this zone, okay, in this zone, these are called as supercritical boilers. So subcritical, critical, and supercritical. So this phase, this you have to understand. Okay, this is being covered in your lower semesters. We will not discuss more deep into it, but this is what is the classification of or the boiler types and efficiency we talk about. Boiler types, we talked about fire tube boilers in which the fire is surrounded by water. So water is in a tank and the fire is made to move in such a manner that the water gets converted into steam. And there is a chimney for the exhaust to take place. So this is a grate. Then there is a ash pit. Then it is fired with coal. So it is a coal fired boiler, or it is a furnace oil fired boiler, or it is a gas fired boiler, and so on. This also classification you can see in the literature. This is the water tube boiler in which the water is placed in the tank and it is being fired with the with fire from the bottom. So you see that this is a low capacity boiler. In this, the steam will be collected in the tank, and that will be taken with the outlet from here and wherever it is required. Packaged boiler. The third diagram is a packaged boiler in which you see the fire is there at the bottom. It is surrounded by a tank with water, and also we have the tubes which are there in the which will carry the heat. So you see this is called as flame. So flame propagation, this is also engineering required for how the flame propagates in a boiler. So there should be a fan, there should be a blower, there should be a pump for feeding the water. So all these are boiler accessories. So boiler accessories are pumps. Then you have the air mixer. So right amount of air is being mixed. So fan we have. So fans, blowers, furnace, the jet of the fire, which will fire from the firing station. So furnace oil, if it is used, it should propagate in a proper manner into the boiler. So this all care should be taken. So packaged boiler, mostly it is used in the industry. So and the this is called as a stoker chain stoker boiler, in which you see that stoker fired boilers. So stokers are classified according to methods of feeding, how the feeding will take place. So it is a chain grade or traveling grade stoker, where the chain will be it is with the help of the sprocket, the chain will be moved in the continuous format. This is the air inlets which will be fired, which will be allowed to make contact with the coal, we can say. So there is a hopper mechanism in which the required quantity of fuel will be passed on the chain. The chain is continuously moving. As it moves, it is all fired. So as it moves to this end point, it will be coming in contact with oxygen, and it will get fired and it will get burned. Okay. So coal is fed at one end of the moving steel chain grate. As the grate moves along the length of the furnace, the coal burns before dropping off at the end of the ash pit. So this in this type of boiler, some skill is required when setting up the speed of the grate or air dampers or baffles. So so to ensure a clean combustion. Otherwise, what will happen is the unburned coal will be passed into the ash pit. This is clear, right? So then we have the uh, spreaded stoker boiler, which is not shown in the diagram, but we have a spreaded stoker boiler. Only addition is that with the help of hopper, it is possible that the lumps of coal may form one above the other, and thereby causing incomplete combustion. So with the help of spreader stoker boiler, we have a spreader which will spread the coal equally with equal intervals on the chain grade. Okay, this is okay for you. Then how to evaluate the performance of the boiler? So there are two methods by which the boiler performance can be evaluated. Before that, some other types of boilers which are used are called as pulverized fuel boiler. Pulverized means powdered form. So coal is first ball milled into powder form, or grounded, we can say, and this grounded or fine powder in the which is around 300 microns, and 70 to 75% of 75 microns. Mostly we have bituminous coal for a pulverized fuel boiler. So this is fired from all four directions into a furnace. Okay, as we see, the firing is uniform for chain grade boiler. For pulverized fuel boiler, we have a continuous fine powder which is fired from all sides, and in between we have a big lump of heat which passes. And in the temperatures, if you want to measure the temperature of such kind of boiler, then we see that around 1300 to 1700 is the temperature, depending upon what is the grade of coal that you are using. So here the incomplete combustion is totally eliminated, but still we find that if the micron size is not properly maintained, then you have incomplete combustion at the end. Then one of my favorite type of boiler is a fluidized based combustion boiler, in which we have also undergone a project with from the final year students, that we have designed this kind of boiler. So what happens with the fluidized bed boiler is, you imagine that it is a solid fuel. Coal is a solid fuel. So even if we grate into a powder form, and if this powder is heated, you see that the top layer of the powder will get heated, but there will be a great difference in temperature with the lower portion of the powdered form of the coal. In fluidized bed boiler, what happens is air is supplied from the bottom of the bed, and this evenly grated or evenly distributed air causes the solid particles to suspend in the air, and it looks like these suspended particles looks like a gas or finely meshed particles undisturbed at low velocity, and this air velocity is gradually increased and a stage is reached when the individual particles are actually suspended in the airstream. So further increase in the velocity will give rise to bubble formation or vigorous turbulence and rapid mixing, and a bed is said to be fluidized. So even though the fuel used is solid fuel, with the help of this air which is coming from bottom at low velocity, then gradually increasing this velocity, then each and every particle will come across this firing range, right? And this bed will become fluidized, and that is called as a fluidized bed boiler. Okay, so what is the advantage of this is proper air distribution will cause each and every coal particle to experience the heat, and fluidized bed combustion has significant uh, advantage because when the firing will take place, eventually there will be no condensable gases. This noxious pollutants are there, that SOx or NOx. These compact boilers will have this kind of incomplete combustions of this, and this SOx and NOx will get accumulated in the chimney because this temperature for SOx, that sulfur dioxide, is very low, which is 120 degrees Celsius. So even if the boiler temperature or firing temperature is 1300 degrees Celsius, when this uh, the burnt coal, when it reaches to chimney, considerable drop in temperature will take place around 120 degrees Celsius, and SOx will try to condensate on the inner portion of the chimney, trying to form the scale of SOx and NOx in the inner part of the chimney, and that the scrubbing of this will definitely affect the chimney, and it can cause damage to the chimney, right? So fluidized bed combustion boiler are very popular when we require very uniform kind of heating. But what is the disadvantage for that? Disadvantage is additional amount of work is to be done by the ball mill to grind this coal to powdered form or pulverized form. Additional amount of work is to be done by one of the by other component, that is a ball mill. Okay, now regarding the performance evaluation of the boiler, there are two parameters by which we evaluate the performance of the boiler. First is the boiler evaporation ratio, which is nothing but steam to fuel ratio. Okay, so steam to fuel ratio is one of the boiler performance indicator. So evaporation ratio means how much steam is generated with the amount of fuel that is being supplied. So you see, this is typically a comparison tool for different types of boilers. If we want to compare coal-fired boilers, oil-fired boilers, and gas-fired boilers in terms of one parameter, that is this, the boiler evaporation ratio. Okay, so you take a note of it that biomass-fired boiler has typically a evaporation ratio of 2 to 3. That means 2 units of steam is generated if I supply 1 unit of fuel. Whereas for coal-fired boilers, the value is 4 to 5.5. So coal-fired boilers evaporation ratio is 4 to 5. Oil-fired boilers is 13 to 14.5. 13.5 to 14.5. And gas-fired boilers is 11 to 13. So once again, I will repeat. You please note it down, or somebody write it in chat section about this. So biomass fired boiler evaporation ratio is 2 to 3. Coal fired boilers evaporation ratio is 4 to 5.5. Oil fired boilers is evaporation ratio is 13.5 to 14.5. and gas-fired boilers is 11 to 13. Right? Then comes boiler efficiency. So there are boiler efficiency means what? The thermal efficiency. Thermal efficiency of the boiler is the percentage of heat input and how it is effectively utilized to generate steam. So there are two methods of assessing the boiler efficiency: the direct method and indirect method. So in the direct method, what happens is energy gain of the working fluid is compared with energy content of the fuel. That means how much is the energy given out by the fuel and how much energy gain by the working fluid is being compared directly. Whereas in indirect method, what happens is it is compared on the mass basis or volume basis, in which the various energy input and various losses are being calculated. So loss through loss with feed water, loss with heating, loss by radiation, loss by convection, loss in the tube. Okay, so these all losses are calculated, lost by excess air, right? So these all losses are being taken into consideration, and we know the calorific value and the mass of the fuel, so we know the energy input, and then comparison is done. So heat balance sheet is being plotted and the efficiency is calculated. So as a mechanical, civil and instrumentation engineering, we will not go deep into indirect method of boiler efficiency evaluation, but we will go for direct method evaluation. So one such example you can solve it by your own, but in general we will discuss more about the direct method is what, that this is nothing but in general terms it is also called as an input output method, that it only requires input fuel and output steam. That's it. So boiler efficiency is nothing but heat output upon heat input. So quantity, what are the parameters to be monitored if you want to calculate the boiler efficiency by direct method is quantity of steam generated per hour in kg per hour, then quantity of fuel used per hour, that is in kg per hour, and the working pressure in kg per centimeter square or bar you can take, and superheat temperature in degrees Celsius if any. That means if it is a superheat, so we have to calculate degree of superheat, the temperature of the feed water, and the type of fuel, and gross calorific value of the fuel. What is the difference between gross calorific value and net calorific value? Is gross calorific value will take into consideration the moisture content in the fuel as well. Okay, and boiler efficiency is given by this formula, Q into Hg minus Hf upon small q into gross calorific value. So this becomes the heat input, this becomes the heat output, Hg minus Hf. If it is a superheated steam, then Cp into T sup minus Tsat. This also you can take. Right. So now, having said this, indirect method is a calculation of all the losses. This is also called as a heat loss method. So what is the advantage of direct method? Direct method, we can have we can evaluate the plant efficiency directly, and it requires very few parameters for computation, and needs very few instruments, by the way. By just by calculating the flow rate of the fuel, just by calculating the pressure values of the steam. So very few instruments are required for monitoring the direct method, for monitoring of efficiency calculation by direct method. Whereas the disadvantages of using direct efficiency is what? Accuracy. So accuracy of the steam flow rate or accuracy of feed water flow will depend upon the instrument that are being used. Even if small errors are there, will cause into a great value of change in the efficiency. So steam quality assessment in case of saturated steam condition is prone to error because uh, prevalence of wet steam is common in many boilers. So even if the saturated boiler is there, it will have some content of wet steam, right? The reported efficiency only gives values with respect to design, but not indicate any improvement opportunities. So where you will improve, whether you will improve in fuel value, whether you will improve in steam side, that is not clear in this type of method. Whereas in indirect method, because you know what is the oxygen content, what is the carbon monoxide percent, then what is the carbon dioxide percent, what are the volatile matters, so what are the SOx contents. So you have the value to decide which parameter is causing this efficiency to drop in an indirect method. But indirect method is very tedious. It will require larger time to calculate. So if you have your, so you will ask me that when I should go for direct method or I should go for indirect method. So if all your process depends upon boiler, boiler is your heart of the system for the industry, then I will suggest that you go for indirect method of boiler efficiency calculation. But but boiler is only a small part that it requires. It gives out only steam, right? And it is used in a very small area of your industry. Then I will suggest you that only direct method is sufficient. And in on top of it, you do individual targeted audit of individual components, that is fans, blowers, pumps, which are the additional accessories for boiler, right? So understood this. If your process heat is your heart of the industry, then go for indirect method of boiler performance evaluation. If your utility requires steam at a very nominal processes, then you go for direct method in addition with efficiency calculation of pumps, blowers, and the fans. Okay. By the way, why the fan will require? What is the role of fan in a boiler? Can anybody tell me in the chat section? What is the role of fan in boiler? Anybody would like to answer? What is the role of fan in boiler? Anybody? To give direction to the steam for proper combustion. Okay. Few more answers, not precise. Anybody? Can you elaborate, Raj? Expansion? Exhaust, yes. Now you are on a right track. So these fans are placed near the boiler exhaust so that the chimney will cause a pressure drop. What we can say, there will be a pressure drop in the chimney. So in order to make these flue gases pass through the chimney, there will be fans. So the role of fan is just to, yes, for fly ash, not just for fly ash, but this fan takes the hot flue gases, right, and into the chimney. So movement of these exhaust gases into the chimney, so that the chimney will dissipate these hot gases into the atmosphere, is the role of the fan. Whereas blowers are used at the air side of the boiler because oxygen is required for combustion and proper amount of oxygen is given by the blower. So if you have seen a uh, if you have seen a if the process of the firing, you see that the oxygen is provided at regular intervals. More oxygen will cause the flame to disappear, whereas lesser oxygen will make incomplete combustion. So there should be a proper arrangement and proper calculation of excess air so that the complete combustion will take place. Okay. Moving further, The energy conservation opportunities in boiler is very important. Such kind of questions are asked in the exam, that what are the boiler energy conservation opportunities in boiler. So one by one we will discuss. So in addition to this boiler efficiency performance, how to improve the boiler performance, you will find a lot of literature is available in the uh, in the book that we referring. So I will circulate that literature with you also, that you can go through it. So blowdown is very important. Boiler blowdown. We will talk about it. So what is the meaning of blowdown, by the way? Boiler blowdown. What is boiler blowdown? Related to shrink and swell? No. So blowdown is nothing but, see, if you have experienced your water heater, the continuous drop and rise in temperature will cause the sediments in the or impurities in the water to get deposited on the inner side of the tubes, water tubes, and this is called as scaling or fouling. So if this same water is circulated in a cycle, because water is getting into steam, steam gets converted into condensate, and this condensate will reach to the feed water tank. So this cycle will continue. So fresh intake of water is not preferred, because we require the water treatment to be done, the de-aeration, demineralization of the water. So this is all energy intensive processes in addition to boiler. Okay, so this is called as feed water pre-treatment of the water. So water gets demineralized, otherwise minerals will get deposited on the inner side of the boiler. So what happens is, after due course of time, this water will lose its tendency, and this material will get deposited on the inner side of the tube. To avoid that, we require the water that is present in the boiler to be thrown out to the atmosphere. This is called as blowdown. So blowdown are of two types. Blowdown are of two types. Okay, we have the manual blowdown and automatic blowdown. So manual blowdown also we call it as a periodic blowdown. So periodic blowdown means what? After some intervals, I know that my water will lose its tendency, and it will get deposited on the all the minerals that are being suspended in the water will get deposited after some usage of the boiler. So I will carry out the manual blowdown, okay, or plant blowdown. And uh, if I so automatic blowdown, this will cause what? The automatic blowdown means what? It will sense, or it will check the TDS of the water, total dissolved solids of the water, and we will set the value, that if it is maximum permissible is this, if it exceeds this value, then blowdown should occur. Okay, so there is complete section is there which deals with this boiler blowdown, which is also called as a blowdown heat recovery system. Okay, so boiler. In addition to boiler, we have this system which is called as blowdown heat recovery system. So, as an engineer or as an energy manager, you can be also appointed as an energy manager to look after this blowdown heat recovery system. Then the waste heat recovery system from boiler. Then, say for example, the condensate recovery system of a boiler, or a complete boiler house will be under your inspection, like that. So role of energy manager is throughout very high role to maintain everything this. Even if small changes in your calculation will reflect into huge amount of savings, and the company will give you incentives based on that. Okay, so understand this process. Now we will talk about first, that is a stack temperature. What is stack temperature? Stack temperature is also known as a flue gas temperature. Flue gas temperature. So stack temperature should be as low as possible. Okay, but I told you that it should not be so low so that the water vapor in the exhaust condenses on the stack walls, or stack temperatures greater than 200 degrees Celsius will indicate a potential recovery of waste heat. So if you find by your measurement, if your calculation, that stack temperature is going beyond 200 degrees Celsius, then you should immediately say that there is a potential heat recovery possible, waste heat recovery possible. Okay, and if you're and I told you that if the fuel contains significant amount of sulfur, low temperature of stack temperature, low temperature will result into sulfur dew point, and it is a good corrosion. It has a good corrosion capacity which can corrode the chimneys. Okay, so stack temperature should be as low as possible, but it should not be so low that water vapor will get deposited on the chimney, or some dissolved gases are there, incondensable gases, which gets converted into the acid dew point, and it will get deposited on the inner side of the chimney, which will cause corrosion. Also, if the temperature of the stack temperature is greater than 200, one must think that there will be a possible waste heat recovery option available with this on the flue side. Okay. Then second point is feed water preheating in economizer. So if you, so there is a uh, relation that normally what a feed water temperature is around 200 to 300 degrees Celsius, then there will be a potential of recovering this heat from the gases. So you can say the stack temperature can be allowed to heat the feed water. This is called as preheating of feed water, and that is done in economizer, right? So you see that even if we increase the feed water temperature by 15 degrees Celsius, 1 5, just by increasing the feed water temperature by 15 degrees Celsius, there is a overall thermal efficiency increase of 3%. Okay, so you can write it down as a fill in the blanks. If I can ask you that if the feed water temperature is increased by 15 degrees Celsius, the efficiency increases by 3%. Very important to know. And what we have discussed in the last class, 1 degree change in fuel will lead to 6 degree change in heating. Right. Then next one is the combustion air preheat. So combustion air preheating is an alternative to feed water heating. In order to improve thermal efficiency by 1%, the combustion air temperature must be raised by 20 degrees Celsius. Okay. So most gas and oil burners used in the boiler plant are not designed for high air preheater temperatures. So, but modern burners can withstand such this much higher combustion air preheat. So it is possible to consider such units as heat exchanger in the exit flue gas as an alternative to economizer, which can increase the air preheat. So in your vehicle, you must have experienced this turbocharging. So turbocharging is nothing but to heat the air, preheat the air with the help of combustion. So the same thing is applicable here, which is called as a combustion air preheat. Okay. Then fourth point is incomplete combustion. So incomplete combustion can arise into various complications, like incomplete combustion will cause the carbon monoxide formation or smoke, right? So the if the fly ash is also there, get carried away, it can deposit in the surrounding, will cause the very bad weather. Okay, so how can we avoid this incomplete combustion? How can we avoid the incomplete combustion? Incomplete combustion can be avoided with maintaining proper air fuel ratio, uniform size, fuel size, in terms of in case of solid fuels, and proper flow of oil and gas fuels. There should not be any small pieces or fines which may block the air passage, then uh, which can cause poor oil distribution. Yes, type of oil. Okay, in case of oil fired boilers. Then excess air control. What is excess air control? So each and every fuel has some oxygen requirement being set. You can find it in literature. If this value is being hampered, then it will result into CO formation, carbon monoxide formation, and excess carbon dioxide formation. So you now think about that if there is carbon monoxide and carbon dioxide formation, then some amount of heat may be transferred by these gases, which can cause the efficiency to drop. And that is why excess air must be controlled. So there is a method of excess air control manually by moving the dampers of the blower, or it can have automatic air control. So automatic air control is also there, right? We can put portable oxygen analyzers or oxygen meters at regular intervals to check whether the excess air utilization is fulfilled or not. Okay, but putting oxygen sensors can be costly. So you can put a flue gas analyzer which can analyze the content of oxygen at the end of the combustion. That will also give you a clear idea of what is the amount of oxygen that is being used for complete combustion. Okay, so oxygen you can use it at the initial part of the boiler in the air preheater portion, or you can use flue gas analyzer at the end of the boiler in flue gas section. Then sixth point is to reduce the radiation and convection heat loss by putting some insulation over the boiler, or with modern design, with boiler designs, right? The next one is automatic blowdown control. We discussed about it, blowdown. So uncontrolled continuous blowdown is very wasteful. So automatic blowdown controls can be installed that sense and respond to boiler water conductivity and pH value. A 10% blowdown in a 15 kg per centimeter square boiler results in 3% of efficiency loss. Okay. So blowdown will cause loss, but the blowdown is carried out in order to increase the life of the boiler. Reduction of boiler steam pressure. Now here there will be two aspects: reduction of boiler steam pressure, and I will also say increase of boiler steam pressure. First we'll discuss about reduction of the boiler. So if you reduce the steam, definitely fuel will be used is less, and that will represent into lesser, or we can say higher efficiency. But if we increase the boiler pressure, then there is a option of cogeneration will be available. So if I increase the steam pressure, stack temperature, higher steam pressure can be expanded first in the turbine to generate electricity, and then this expanded low temperature steam can be used for process utility. Okay, it is being found that increasing the boiler pressure and using cogeneration system is always advantageous and efficient. Okay, then next one is variable speed controls for fans, blowers and pumps. So variable speed control, we have already discussed that the power is proportional to fourth power of RPM. So if we reduce the RPM, definitely there will be reduction in, instead of using throttle devices to control the air, we can use these variable speed drives to control the flow of air from fans, blowers and pumps. Okay. Then effect of boiler loading on efficiency. The maximum efficiency of the boiler does not occur at full load, but about 2/3 of the full load. So if the boiler operates at 2/3 of the loading, then it is highly efficient. So this must be known. So you have the boiler startup time. There are methods to reduce the boiler startup time, and the boiler should not be run at the full load, but it should be run at 1/3 of capacity. Okay. Then next one is scheduling of the boiler. So the optimal efficiency of the boiler occurs at around 65 to 85% of the full load. and it is usually more efficient on the to operate a fewer number of boilers at higher load. So for example, you have 3 boilers in your setup in your boiler house. So instead of using all 3 boilers at same pressure or half load conditions, we can use only 2 boilers at full load condition. Okay. So in general, what we can say is uh, operating large number of boilers at low loads is less efficient than operating few number of boilers at high load. Okay. So it is uneconomical to operate large number of boilers at low load conditions as compared to operate a small number of or less number of boilers at a high load. Then last option will be boiler replacement. So boiler replacement, so you cannot say as a energy manager that this option is okay for me, correct for me at all times. This should be the last option. Boiler replacement should be the last option when you see that the boiler replacement should take place, or financially attractive option of boiler replacement is you must first know that the boiler life is well over 25 years. Once you install a boiler, you have so whenever you are setting up your industry, you and your boiler is your prime utility, then you have to plan according to 25 years. You should see that how my business grows for 25 years. So you should wait for, say for example, in 5 years time your production is doubled, so your boiler is now inefficient to supply this full load condition. It is should not be overload. So when you purchase a new boiler, you should purchase 2 boilers. One as the one will be used for the setup and one will be for auxiliary use. If there is some problem with the boiler or overhauling is required, then the other boiler should be in a standby mode. Okay. So all uh, financially attractive solution for existing boiler is replacing of existing boiler is the boiler has become old and inefficient. If the boiler is not capable of firing cheaper substitution fuel, okay, that means example is, let us say that there was a oil revolution and furnace oil price dropped. So you purchased a furnace oil fired boiler. Suddenly, after 5 times, you realize that the furnace oil price have increased to 3 times, and you want to now shift from furnace oil to coconut chips fired boiler. So same boiler will not be used or will be feasible for use to have coconut chips fired boiler. So in that case, you can buy a new boiler which is capable of firing a cheaper substitution fuel. The boiler has become over or undersized for present requirement, then you can think of replacement of boiler, or it was not designed for ideal loading conditions, then you can go for boiler replacement option. Okay. So this is it. Now you can ask me questions if you have. Anybody would like to ask some questions?